Today is Saturday, September 27th. Animals we've only seen in movies or textbooks are seemingly coming back to life. A company called Colossal Biosciences made headlines again this month, announcing a breakthrough that could bring back the extinct dodo bird within a decade. You might remember this company as the one who already genetically engineered 3 dire wolves, the first to live in over 10,000 years. So, how does so-called de-extinction work? What challenges and ethical questions come with it? And how could these same technologies actually help save endangered species or even shape the future of medicine and agriculture? Our guest today is Dr. Beth Shapiro, Chief Science Officer at Colossal Biosciences. She's an evolutionary biologist, a professor at UC Santa Cruz, and a MacArthur Genius Fellow who has spent her career using DNA to study everything from Ice Age animals to modern conservation efforts. She's here to explain the science, answer to some of the criticism, and speak about the future of bringing back the past. Welcome to the Newsworthy Special Edition Saturday, when we sit down with a different expert or celebrity every Saturday to talk about something in the news. Don't forget to tune in every Monday through Friday for our regular episodes, when we provide all the day's news in just 10 minutes. It's fast, fair, fun, and on the go. I'm Erica Mandy. It's time for today's Special Edition Saturday. You ready? Let's do this. Beth Shapiro, thanks so much for joining us here on the Newsworthy.
I am happy to be here.
So first, just give us an idea of how Colossal Biosciences began, how it was founded, and what's its main mission.
Colossal is a de-extinction company and a species preservation company. And it's both of those things, I think, that are most important to me. I joined initially as an advisor when they were founded several years ago to bring a mammoth back to life. I'd been working in the field of ancient DNA for a long time, and I'd written a book called How to Clone a Mammoth. And so I think when Ben Lamb, who's the CEO, saw my book title, he thought, for sure, that's the person we need to get on board.
And so my understanding is that a mammoth is coming, but so far you've created a dire wolf.
We've announced 3 different species over the several years since Colossal was founded. The first was the mammoth, and then the thylacine, which is also the Tasmanian tiger, an apex predator that lived in Australia. And then later on, when I joined the company, we announced that we were launching a program to bring the dodo back from extinction. And that means that we have a placental mammal, a marsupial mammal, and a bird, which means that we have opportunities to develop technologies that can be used to help species avoid extinction that are across a pretty broad part of the animal tree of life. That is something that I really value about the work that I get to do every day. And so why then were those 3 species not one of the first that we announced? Well, every species that is a candidate for de-extinction faces a different suite of technical and ethical and ecological challenges that we need to find solutions for. And these 3 are hard. We really don't have technologies right now to be able to edit the DNA of birds and pass them to the next generation. And the mammoth, well, mammoths have a mammoth-sized list of challenges. And so we were sitting around one day, a couple of years ago now, and going through the list of other species that could potentially be targets for de-extinction. And when we got to the dire wolf, there are so many things about that species that check so many of the boxes you want to check when picking an animal that we thought this is something that really could be a fantastic first de-extinction. Not only is there a genome, we could do that work with our academic partners, the surrogate is a gray wolf. And this is a species that we know a lot about genetically, but also in terms of how to keep them happy and healthy in captive and semi-captive breeding environments.
So back up and tell us a little bit more about the general idea of how this works.
There are lots of different technical steps that we approach simultaneously with different teams. So we have to know what DNA sequence changes we need to make. Because this isn't like Jurassic Park. In Jurassic Park, the scientists went out and they got DNA from mosquitoes that were in amber. I mean, there's a lot of this that is not like Jurassic Park. I should back up and say that's not possible. There is no DNA preserved in mosquitoes in amber. I've actually tried it because, I'm an ancient DNA scientist and, I want to know. But so that's not going to happen. Instead, what we're doing is starting with something that is already really closely related to that ancient species. So in the case of the mammoth, we start with an Asian elephant. and their DNA sequences are already 99.6% identical. What we need to do is change the rest of it, the parts that are really important to defining a mammoth as a mammoth instead of as an Asian elephant. So we sequence a lot of mammoth genomes from bones that are preserved in the Arctic mostly, and we line them up against each other on a computer, and we figure out where they are all the same as each other, but different from elephants. And that is a potential target list of the DNA sequence changes we need to make. That's going to be many millions of sequences and many millions of edits. And of course, we can't make that many right now. So the next step is, let's figure out which of those are most important. And for that, we use a combination of approaches. Then we have to learn all sorts of other things that we'll need to do. How do we develop the animal reproductive biology knowledge and background and tool set that we need to make sure that we can do this in a way that results in the birth of healthy animals? We have teams working on all of these challenges simultaneously, and as we make insights, as we make discoveries, we then can also apply these to different projects.
What is the timeline for the mammoth?
We have deliberately not given timelines for most of the species that we are working on, and that is because we have to solve a lot of very hard scientific challenges. And I want my scientific team to be able to work toward internal timelines that we give them, but at a pace that means that they have the capacity to push back when they think things are going too far or going too fast, or we can ask the important questions that need to be asked. When Colossal launched, they did say that they thought that the first mammoths would be on the ground by 2028. That would mean, because of the 22-month gestation, we would need to have a pregnant elephant in 2026 or early 2027. Our teams are on track to be able to deliver a cell that has edits in it in order to make that deadline. But animal reproductive biology is hard, and especially when it comes to elephants. And I am not willing to risk health of elephants to push through a deadline that we don't need to push through.
I want to ask, because I know Colossal has faced some criticism about using the term, let's say, dire wolf, since some people might argue that it's not actually a dire wolf. Can you describe what the debate is there and your response to that?
I think the reason that this is so hard is that there isn't any existing species concept that can accommodate the way that we have made our dire wolves. Now, if you're a species purist and you say the only way I'm going to let you call that a dire wolf is if you have made every single change so that you're mimicking a very specific dire wolf individual that used to be alive, then of course you're never going to be satisfied with that. But if you're satisfied with, well, what you've done is you've recreated something that looks and acts like a dire wolf, then you're going to be satisfied with that. So we're choosing a definition that calls them dire wolves because they look like dire wolves. When we talk about de-extinction and what makes a successful de-extinction, we look to a white paper that was produced by the IUCN a couple of years ago, many years before I got involved with this, that says that a de-extinction is successful if you've brought back some semblance of an extinct species. So we combine these two and we say, our wolves, Romulus and Remus and Khaleesi, are dire wolves because they have dire wolf DNA and they look and act like dire wolves in the way that we intended them to.
And so then what's the goal for these animals once created? Where are they now? What's the latest? And where do you see them going in the future?
The goal for Romulus, Remus, and Khaleesi is that they will live out their lives in a secure, expansive ecological preserve where we can monitor everything about them. We want to learn how they interact with each other, how they interact with other species, how they interact and maybe modify pieces of their habitat. Again, looking to this document that was prepared by the IUCN, they point out that the next phase of de-extinction, before one can release animals into the wild, is to really fully understand and document the impact of the DNA edits on the animals and of the animals on the environment. And so that is our goal with Romulus, Remus, and Khaleesi. A few weeks ago, we introduced Khaleesi to her brothers for the first time, and we're thrilled to see that this went really well. They had been allowed to smell her and be around her and see her for much time, but they hadn't actually been in the same enclosure because they weren't born at the same time. And we were a little worried that this might not go well, but if people are interested, there are some really adorable videos that you can find on our social media where you can see Khaleesi and her brothers frolicking happily together in their secure and expansive ecological preserve. The goal for other de-extinction species is, of course, that we will eventually release animals into the wild. And that is true for the mammoth and the dodo and the thylacine and the MOA project, which we announced more recently. These will all be staged. There is no world in which we would spend so much time and energy and resources to creating animals just to release them into a habitat. We also have to remember that we operate within the regulatory environments in which we work in any country, and there isn't a way that we would just do that. So just to quell people's fears, we care about these animals. We really want to understand that they're healthy, that they're able to interact with the environment and do the things that we intend them to do, restore missing ecological interactions to communities to help reinvigorate those communities.
Still ahead, criticism and concerns about playing God and how Colossal responds, and the unexpected ways this science could impact conservation, agriculture, and even human medicine. That's coming up, but first, a break for our sponsors. The Newsworthy is brought to you by BetterHelp. Life can feel like a lot, and while friends and family are great and supportive, sometimes I just want to enjoy their company without getting into any of our concerns. Plus, let's be honest, most just simply don't have the training and credentials to always know what to say or give you the best advice. And that's where a therapist comes in. For me, having someone trained to listen, ask the right questions, and push me in a supportive way has made all the difference. And if you're not sure where to start, BetterHelp makes it easy. They've made it simple to connect with a licensed therapist online, just a quick questionnaire, and you're matched with someone chosen for your needs. And yet, if it doesn't feel like the right fit, you can switch therapists anytime at no extra cost. As the largest online therapy provider in the world, BetterHelp can provide access to mental health professionals with a diverse variety of expertise. Find the one with BetterHelp. Our listeners get 10% off their first month at betterhelp.com/newsworthy. That's BetterHelp, HELP.com/newsworthy. The Newsworthy is also brought to you by OneSkin. When I first started using OneSkin, I was not quite sure what to expect, but I've been pleasantly surprised at just how much I've liked all of their products, from their face and eye creams to their SPF. They feel great, and they're backed by real science. For those of you familiar with OneSkin already, you know how their OS1 peptide is scientifically proven to target aging at the cellular level. Now it's targeting your scalp too, because your scalp is skin. OneSkin created OS1 Hair, a lightweight, drug-free serum that supports a healthier scalp, which means healthier, stronger hair. And the results are impressive. In a clinical study, participants saw, on average, a 40% increase in hair density after 6 months. And in a consumer perception study, 75% had new hair growth after just 3 months. OneSkin is the world's first skin longevity company. By focusing on the cellular aspects of aging, OneSkin keeps your skin and scalp looking and acting younger for longer. For a limited time, you can try OneSkin with 15% off using code NEWSWORTHY at oneskin.co. That's 15% off oneskin.co with the code NEWSWORTHY. And after you purchase, they'll ask you where you heard about them, so please support our show and tell them we sent you. Now back to my conversation with Beth Shapiro from Colossal Biosciences. What's your response to concerns about unknown long-term consequences, either for the animals or the ecosystem, or just this critique that this company is trying to play God?
I think in any situation where we're talking about a new technology or we're talking about a new intervention, there are always going to be risks that we can identify and risks that maybe we can't identify. I think as we work toward release of de-extinct species or any conservation intervention, we can do everything in our power to evaluate what potential risks there might be, to come up with potential solutions to those risks or to mitigating those risks. But I also think it's fundamentally important that we remember and acknowledge the risk we take by not allowing ourselves to push forward with some of these biotechnologies that are at our fingertips. We are in the midst of an extinction crisis, and we need better tools, more resources, better opportunities if we want a future that is both biodiverse and filled with people.
Why de-extinct ancient animals? Why not take a species that has gone extinct more recently?
Why not do all of it? Why? That's very similar to the question that we get of why do this instead of develop tools for preserving species that are in danger of becoming extinct? And I would argue that they are the same tools. By building the technologies to bring mammoths and dodos and thylacines and moas back to life, we are developing technologies that will allow us to help honey creepers, become resistant to avian malaria, which people introduced into their ecosystem so that they do not become extinct. They are the same tools. And by pushing and motivating toward this moonshot goal of bringing these extinct species back to life, we are developing technologies that are going to stop species from becoming extinct. It's the double billing as a de-extinction and species preservation company that motivates me when I go to work every day. I want to see a future where we have a more robust toolkit of things that we can draw from to stop species from becoming extinct, to help ecosystems recover from the insults that are brought about by both natural and human-caused changes every day.
And do you see it becoming a tool for human medicine or agriculture as well?
Absolutely. We already have these sorts of tools being developed for human medicine, and I think there is a ton of funding and research and resources that go into that, way less so for agriculture. And if we want a future that has people in it, 10 billion people, and we don't want those people to be starving, we have to get to a point where we are able to turn the fewer and fewer resources that we have, the less and less arable land that we have, into food for people. And it is these exact same technologies and the same regulatory pipelines, the same ethical guidance that will go into creating a future where we have food security for people in the world.
So you addressed the movie Jurassic Park, which has come up a lot, I think, when the Colossal gets discussed. But do you still envision some sort of zoo of de-extinct species or any similarities to that kind of Jurassic Park vision?
That's a great question. I mean, it's not in our business plan. We're really hoping that we can generate these species, and we're developing technologies that have utility across the agriculture space and human medicine space, and the technologies that we're developing that can be applied to conservation, we are giving away to conservation partners for free. So we're really hopeful. I'm really hopeful that what we have is a world where wild habitats have wild animals that are healthy, and that some of those wild animals are de-extinct species.
And I think it's fair. People might wonder, what are the financial goals? Like, how does the company foresee making a profit in the future?
There's a lot of technologies that need to be developed that have application outside of the conservation arena. We have a team of people that's making an artificial womb with the plan of not having to use maternal surrogates to bring mammoths back to life, for example. And as we develop artificial womb technology, this has obvious application to human health and also to the agricultural space. We need to develop technologies for multiplex genome editing and engineering and cellular health maintenance, and all of those have application to human health and management. We've already spun out one company, Form Bio, that has created a software platform that we've been using. And really the financial future of Colossal is in technology development, as well as potentially some application in the carbon space in the future.
What's one thing you're most excited about in the near future for Colossal, and any other final thought or takeaway for our audience?
I'm particularly excited about work in the avian space. We currently don't have technologies that allow us to pass DNA sequence changes through bird generations, except for chickens. And yet birds are some of the most endangered species on the planet. And as we push toward the dodo and the moa, we are going to develop tools that we can use to stop birds from becoming extinct. And I am very excited about that path and that future. One of the most exciting things about Colossal is that everything we hear about conservation, about the future of the world, is depressing, right? And I have 2 teenage boys, and they study science, and they come home and they say, what are we going to do? Like everything we get in our scholastic news or in these other things, they just say that there's not going to be enough food, that species are going extinct, that waterways are getting polluted. And then we launched the dire wolf and the red wolf, and everybody came home talking about a future where their generation was going to be able to have a better future and make their children's future even better. And that, I think, is a really important point about Colossal. It's exciting. It's generating enthusiasm. It's giving people hope in a time where we don't get a lot of that. And I am really happy to be a part of that.
Well, thank you so much to Beth Shapiro for joining us. As always, we'll be back on Monday with the regular news you may have missed over the weekend. We keep you up to date on the latest happenings and other interesting headlines every Monday through Friday, all in just about 10 minutes. So join us again next week. Until then, have a great rest of your weekend.